Hello everyone, myself Pratiksha Thora. Today I am presenting retail store prediction, that is a ML regression problem on Rossmann Store. I am doing this project individually. So this data set is live data set for data set of Rossmann stores. On analyzing this problem, we observe the Rossmann problem is a regression problem, and our primary goal is to predict the sales figures of Rossmann problem. In this project, I have attempted to analyze the retail sales data set of Rossmann store and build a predictive model forecast the sales of any Rossmann store for any date. No personal information of customer is provided in this data set. So analyzing we are solving this with analyzing the data set using exploratory data analysis, using exponential moving averages analysis, trends and seasonality in the Rossmann data set, analyze regression analysis using following prediction analysis: linear regression, elastic regression, lasso ridge regression, random forest regression, and the Abad boost XGBoost. Then the problem statement of this project is to develop a machine learning regression model that accurately predict the daily sales up to 6 weeks in advance for 1115 Rossmann store across the Europe. The model should take into account various factors that influences store sales, such as promotion, competition, holiday seasonality, and the locality. The ultimate goal is to help the Rossmann store managers to inform the decision regarding inventory management, staffing and promotional strategies, leading to increased sales and profitability for the business. So we have given the two types of data. The data is in two files. The first one is Rossmann store data, that is historical data including sales, and the second one is store CSV, that is supplemental information about the store. And this data contains ID, that is unique entry ID, the store that contains store ID, sales content made for the day, and the customer footfall for the day, open or the closed, that means 1 or 0. 1 means open and 0 is closed. State holiday, if there is a state holiday or not. Then the store types, then assortment, types of stores, then the competition distance, that means the distance from the competitor store. Then the promo, if the store is running a promotion or not. Then promo 2, that means the store running consecutive promotion or not. Let's start. So first we are importing the libraries that we needed, like numpy, pandas, matplot, seaborn, plotty pandas, etc. I have mounted this into my drive. Then we are gonna load the data sets. We are gonna name sales DF for the Rossmann store data and the store DF for the store CSV. So for the first look, here we get the first look of the data set. In this data set we get first 5 rows. In here we get last 5 rows of the sales data. Then we get first 5 rows of store data. Then we get the last 5 rows of the store data. Then we get 55,813 rows and 9 columns for the sales data. And for store we get 1,115 rows and 10 columns. We get column names also, and the column names of the store data also. Then we are getting data information. We get data is information like there are integer, float or objects, non-null, null values, etc. Then we are getting a description like count, mean, minimum, percentage of the data set. This is for sales data set. This is for stores data set. Here we get so many floats. So then we are getting description for the store data sets here also. we got a duplicate values also. We count null value in both of the data sets, that is sales and store data set. Then we are visualizing the store and sales data set. So in understanding the variables, we got these like rows and column, and understanding our data set, we got none values also. Here we can see that none values, nan values also, and we got the unique, top, frequent, mean, standard, minimum, and percentage values also here. This for sales and this is for store. Then we already described these variables. Then we are checking the unique values, like we got in sales 10 and nan value is unique value for it, and in store value there are so many. So here are the data set fill into null values, that is 0. Then we deleted that null values from it. Then we got 0 null values when we again printed the is null value. Then we can see that up to here we got so many struggle to analyze the two data set values, so we are going to merge them. So here we got merged the two data sets into naming them total data set. So this is the first look of our new data set. Then we got unique values of that data set. Then here are we changing the object to integers. Then we are printing the unique values of these columns, I mean variables. Then we got info again about the total data set. Then here are we have calculated the value counts here. Our data contains we are changing the date from the object to date time. So here we change it, and we got new dataset info. So in all this manipulation we got that data contains 10,1719 rows and 18 columns. It's about the total number of rows and column. That means the merged columns and rows. The data set is from 1st January 2013 to 31st July 2015. That is approximate 2.5 years. Data type. Then I checked the missing values. There are few missing values with the competition distance and the promotion since column. I have filled these missing values with the median value of those columns. I have checked the outliers with the few outliers in the sales column. I have removed these outliers by using 2K method. Then I have converted the categorical feature to the numerical feature. The store type and assortment columns are categorical feature. I have converted these columns to numerical feature. I have split the dataset into training set and test set. I have used 80% of the data as a training set and the remaining 20% of the data is the test set. So now we are starting data visualization, storytelling and experimenting with the charts. So let's begin. So here we have made the chart of figures based on variable. We got all of the variables in here, like a day of week, open, promo, state holidays, school holidays, and assortment, competition, promo, store type also, assortment also, competition, open since month also, promo since year. So there were more sales on the Monday, and probability because the shop generally remains closed on Sunday. It could be seen as a promo leads more sales. On an average, store type B had the highest sale. Highest average sale were seen with the assortment level B, which is extra. With promo 2, slightly more sales were seen without it, which indicate there are many stores not participating in the promo. So the next chart is to find when we should refurbish our store. So we can see this chart, and we can see that first that is Sunday, and 7 is that is Saturday have the huge sale rate, and there is a lowest sale rate on the 6th, that is Friday. So for refurbish we should close the store at Friday. So in next chart we can see here sales of the store is affected which continued their promotion. The sale is in 2013 and 2015 are very low in spite of promotion. The reason can be more competition year by year. So we can say that there are the store should promote themselves on social media to get faster result. So in the next chart we see here sales have been growing steadily over time. The rate of growth has been slowing down in a recent year, and there was a slight decrease in the sales have rebounded since then. So next we have make a pie chart. In this chart we can see that the majority of the store are physically stored 68.2%. There is a small percentage of online store like 13.5%. there is a small percentage of other types of stores also, that is 18.3%. So next we are graphing a box plot. Here we can see that the distribution of sale is skewed to the right. There are few stores that have very high sales. The average sales are around $1 lakh, and the median sale is around $50,000 in the we have in next chart we can see here the sale are slightly higher during school holidays than during non-school holidays. We can see the difference. In this promo chart we can see here the stores who are promoting their store have a higher sale rate. In this state holiday chart we can see that sales have been steadily increasing over time. The rate of increase in the sale has been slowing down in recent years. And in next chart sales are significantly higher during holidays and than during non-school holidays. We can see the difference also here. So in this scattered graph we can see that there is a positive correlation between the sales and the customer store, which is more customer tend to have the higher sales. The impact of customer on sale increases as the number of customer increases. There are some outliers of the data, such as the store with the highest sales and the store with the lowest sales. So in this density chart we can see that the world's population is not evenly distributed. There are a few regions with very high population density. These regions also have larger populations. So in this scattered chart we can see that from the above scatter plot we can observe the mostly competitor store weren't that far from each other and store densely located near each other saw more sales. In this chart, the two variables are sales and competition distance. The dots were individually stored, and the x-axis represent the competition distance in meter, and the y-axis represents the sales in Europe. The chart shows that the negative correlation between the sales, competition and distance. This means that is the competition distance increases, the sales tend to decrease. This is to be the expected, as stores with the more competitive are likely to have the lower sales. So next we plotted the correlation heat map. So in this heat map, we can see that day of week has a negative correlation, indicate low sales at the weekends, and the promo customer and the open positive correlation. So next we have pair plot. In this pair plot, there is a clear relationship between number of customers and sales. As the number of customer increases, so do the sales. This is to be expected, as more customer means more potential sale. The day of week also have the impact on sales. On average, sale is highest on Saturday and Sunday, and lowest on Wednesday and Thursday. This likely to be a factor more likely to be people shop on the weekends. So next we are starting with feature engineering and data pre-processing. So here also we plotted the correlation heat map. First we will see through EDA conclusion and a hypothesis validation. There is a positive correlation between customer and sales, which is exploratory. Here it will be deducted that there will be more sale on Monday, probably because shops generally remain closed on Sunday, which had the lowest sales on the week. The positive effect promotion customer and sales observation. It is clear that most of the store remain closed during state holidays. And the next, feature engineering and data pre-processing. Here we also plotted the correlation heat map. Here we can see that the color of the cell indicates the direction and the strength of the correlation. A positive correlation is indicated by the warm colors such as red colors, and a negative correlation indicate the cool colors such as orange colors. Like these are the intensity of color represents the strength of correlation. So next we are gonna handle the missing value like this. Then we are handling outliers here. Then textual data pre-processing. And now we are analysis to target variable, that is sales. So we plotted the histogram that showing the sales and the so in this we will drop those stores which sale is 0, assuming that that is sales and store. So the stores which have 0, that assuming will be the closed temporarily, and this will be the help to train the model more accurately. So next we are filtering and dropping rows with both open and sales are. Then we have dropped then we are making a new data frame with dropping rows both open and sales. So we dropped them, and we got a new data frame shape and the new data frame. In new data set, column name promo interval changes dummies in means that each new column have the binary value here. Like here. Then next we are gonna perform one hot encoding here. Then there is our new data set. Then we are performing hypothesis testing. In hypothesis testing, we are gonna make a ML model, one that is excluding rows which has sales 0, and the other by making the whole data set. Then now we are importing the libraries which are needed for this. In ML model 1, as we have two datasets, first one having sales 0 rows and another excluding, we will be both dataset based model. First we will take dataset excluding sales 0 rows like this. We are here we are creating independent variable, then splitting the dataset, then here we train the model, then checking regression, that is r square value, then checking the coefficient difference, then checking the intercept difference independent column, then predicting dependent variable with the dataset, then original dependent, and then predicting on trained dataset, then dependent variable with trained dataset, that is 80%. Then we are calculating MSE and in RMC for the test prediction, calculating the R square score between the true target value, that is y test predicting values. We got these actual and predicted. Then we are installing the SHAMP and LIME in our notebook. Then we are gonna load the Rossmann data set, then convert the date column into the data time format, then extracted the month and the day from the week, the date column, then split the data set into training and test, and we got this SHAP value graph. Then we are going for lasso. In here we import the cross-val score function, skitlearn, and creates a lasso regression model with the specific hyperparameters. We got this lasso. In trained lasso regression model 1, L1 makes prediction the test data X and the store predicted values, and we got the score like a 0.14, then providing the estimate of its generational ability. Then we got the scores like here, then the mean score is 0.75, then we get the grid search estimator lasso. Here we get best alpha lasso like 0.2, then best score lasso is 0.76. We get this actual and predicted graph also. Then we train the ridge model using the provided training data to learn the relationship between the feature and the target variable here. And now we get the best alpha value, that is 0.5, best score is 0.76, maximum CV score is 0.77, and corresponding alpha value is 0.5. Then elastic, we make a elastic net, it has similar value, then we make a decision tree. In here we make a sales mean, we got 5,773.81 sales mean. Then we added dependent variable in it, then the sales value got changed. We got 6,955 here. Then we are going to ML model 2, that is by making the whole data set. In dataset, total DF column name promo interval changes into the dummies. It means that each new column will have the binary value 0 or 1. So total DF is equal to, we got the promo interval, and then we get the total DF head of that after this, and then we define a dependent and independent variable and convert them into arrays. So here we convert them into arrays. And then here we create the data independent variable, then create variable, we get arrays and v value also. Then we got the total independent variables here. Splitting the data set, we got the splitted data set here. Then we are going for a linear regression. First we going to scaling the x values, then we are fitting the data into the linear regression model. Then we use the trend linear regression model to make prediction on the test dataset U. Then we get the linear regression score, that is 0.8677. Then we got this actual and predicted values also. Then we are calculate and print the mean square error. So we get the MSE, that is this value, then RMC also, then RAMPSE also, then R2 also. Then we are gonna make a decision tree. In decision tree we are the regression model to predict the target variable. So we also get the MSE, RMSE and RMPSE and R2 value here also, and we got the actual and predicted value also. Then we create random forest regression and calculate the mean square error also. We are calculating the root mean also, and the coefficient and determination also, and we got those values. Then importing XGBoost as XGBoost, we got the XGBoost values also. Here are the values. So at last the conclusion, we saw the sales column containing 1,72,817 rows and with 0 cells. So we created a new data frame in which we removed 0 cells rows and tried to train our model. We used various algorithms and got accuracy score around 74%. We were also curious about the total data set, so we trained another another model using various algorithm, and we got accuracy near about 92%, which is far better than the previous model. So we came to conclusion that the removing cell 0 rows actually removes the lot of information about data set, as it has the 1,72,817 rows, which is the quite large, and therefore we decided not to remove those values. We got our best RMPSE score from the random forest model gradient boosting technique like AdaBoost, XGBoost. We tried making an optimum parameter so that our model doesn't overfit. So at last I thanks to Almabetter to giving me this platform to represent my project. Thank you so much.